Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, minimum cost to convert strings to. The problem is very interesting and bit hard as well, but as always, I'm very confident that if you stick till the end, you will be able to understand everything behind this problem. At the end, I will be discussing one small follow-up, which is basically an optimization of this solution itself. That is, it will work for larger constraints as well. So all the timestamps are there in the description down below. Feel free to move back and forth in the video and watch the section you like. So with that, let's get started. Also, before solving this, I would encourage you to solve this problem, minimum cost to convert string 1, because these two problems are somewhat related and this is an harder version of the previous problem itself. So if you haven't solved this yet, I would encourage you to solve this one first. I already have a detailed video solution for this particular problem. I will link that somewhere in the description down below or top right hand section. So I'm assuming that you already read the previous problem, so let's start from that. The only difference here is, instead of character, we now have strings. That is, we can pick a substring original I from the original string source and change it into changed I of target with incurring a cost of cost I, right? In the previous question, we just take one character, convert it into a different character with some cost. Now we are taking a substring, convert it into another substring, and with some cost I. So there are some criteria as well, which we need to follow while applying the operation. We'll come to that criteria later, because the given examples might not help you understand this better. So the objective is same. We need to return the minimum cost to convert the given string source to the given string target, and we can use any number of operations is not an issue at all. And if it is not possible, we'll return -1. So let's take an example. Let's say source is this, let's take this one. Source is this, destination is this. Now original is B C D F G H D H H and changed is C D T H H G H H. It means that to change, you can take a substring BCD from this string, convert it into CDE with a cost of 1. Similarly, you can take FGH, convert it into THH with a cost of 3. So one of the ways to convert this string into this string is take this substring BCD and convert it into CDE. And if you convert into CDE, you can see these 4 characters are now matching. ABCD will convert it to be ACDE, which is exactly equal. Now after that, you can convert this FGH into THH, right? But the final string is GHH, so there is a conversion from THH to GHH as well. So you will do that conversion again, and finally with just 1 plus 3 plus 5, 9 cost, you are able to convert the given source string to the target string. And you can try out any other possible ways. You will not be able to convert the given source to the target string in less than 9 cost, and hence the answer here is 9. So let's take one more example to understand the problem a bit better. So let's say this is the original and the changed array. Basically, to convert BCDA into DDDD, you incur a cost of 4. Similarly, to convert BCDAF to ABCDF, you can incur a cost of 6, and so on and so forth. And your target is to convert this string into this string. Now how will you do that? I would encourage you to pause and try to come up with various possible approaches to convert this string into this string and see what is the answer here, because that will help you understand the problem a bit better. So there are 3 possible ways here. One is you take BCDA and convert it into DDDD, right, with the cost of 4. Now after you convert into DDDD, you can take this string or this substring ADDD and convert it into AABCD, which is equals to which will make the string equals to the target string. So you did this with a cost of 1. Now another possibility could be you take BCDA and convert it into DDDD, again with a cost of 4, the same operation, but this time you take this string DDDD and convert it into ABCD itself with a cost of 3, right? So here you incur total cost of 5, here you incur total cost of 7, and finally what you can do is you can take BCDAF and convert it into ABCDF with a cost of 6. So in this case you incur total cost of 6. Now here is when the two criteria mentioned in the problem statement comes. One of these three scenarios is not a valid transformation. Which one? The first one. Why? Because as per the problem statement, you are only allowed to choose two operations if they are disjoint or they are exactly identical, right? So if you are taking or if you are replacing a substring A to B in the source string and C to D in the source string, either AB should not overlap with CD or AB should completely overlap with CD, that is A is equals to C and B equals to D. So in this scenario, in first scenario, we can see this was the first string, we converted it to DDDD. Now after that we took this substring. Now this substring is overlapping and it is not exactly equal. Previously you were considering substring starting from index 1, but now you are considering substring starting from index 0. Because these two substrings are not equal, this transformation is not a valid transformation for the given problem. Whereas this is a valid transformation because here as well you are picking an overlapping string that you have already transformed, but this time the overlapping string is exactly equals to the original string. So original substring started from 1, ended at 4. Here as well the string started at 1 and ended at 4. You are transforming exactly this string to something else. So this is allowed. So because only two valid ways are there, we will take minimum of 6 and 7 and the answer would be 6 here, right? Now this will help, like this thing whatever we have done till now has a strong inference. I would encourage you to pause and understand or try to think what exactly is the inference here. So hope you thought about it. The inference is that if you have touched a string before and converted it to something else, you are not allowed to touch the same string again unless it is exactly the same string. So if it is exactly the same string, it is, you can say that okay, you have converted, let's say some substring xyz to some abc, and then you converted this same to, let's say, def. So you can come forward, like you can follow this chain and convert finally xyz to something else. Now once you have converted, here xyz is, let's say, bcda, you have converted this bcda to abcd by following some transformation. Now once you have done this, you are not allowed to touch this part again. Why? Because the next string should not or should never overlap as per the problem statement. So this means once you have understand, or once you have decided that you will transform something, so let's say you decided that you have to transform bcda, so you better transform bcda to final value of those characters in the final string. So basically you will transform bcda to abcd. If you are not able to do that, you will never be able to transform this source string to target string, because If you leave BCDA in between, let's say you didn't transfer to ABCD, you transferred to some ABD. Once you did that, you are not allowed to touch this part again. So this will remain ABD forever, which is not equal to target string, right? So the inference is, once you touch it, you better transform it all the way to the target value. Otherwise, there is no point touching it at all, right? So this is basically the main piece of the problem, and if you have understood this, I think most of the problem is solved. So I would, if you have watched till this point, this is the right time to pause and give this problem another try if you haven't did it yet. So now we have to transform this string to this string again with the same set of replacements or transformations. Now think about it. For a single character, so let's say you are first focusing on the first character, so either it will be same. If it is same, there are two choices: either you will touch it or you will not touch it. Why you will touch it, we'll come to that later, but let's say you didn't touch it for now. Your theory is, if it is same, I will not touch it, and that kind of makes sense as well in some intuitive way, because if you are touching it, you are incurring some cost, so it's better not to touch it. But in this case, that's not really true. We'll come to that. But for now, let's say you are not touching it. Now if you are not touching it, what you are saying is, what is the total cost, or what is the minimum cost to convert this remaining string into this remaining string? Isn't this problem exactly equal to the original problem? Original problem was, what is the total cost to convert this string into this string? Now you are saying, what is the total cost to convert this string into this string? So hope you get the sense of recursion here. So let's take one. This is the scenario where you are not touching anything, but let's take a scenario where you are touching something. So let's say you decided to touch this B, right? Now you have to remove this B with something. So you have couple of choices here, or you have few choices here. One, you replace this B alone, and if you touch this B alone, your target is to convert this B into this A, because we already discussed, if you are touching, better to convert it into the target form so that your final string is reachable. Otherwise you will never be able to make the final string, because you are not allowed to touch it again. So if you are decided to touch only B, your target is to convert B to A. And let's say you are able to do that. Let's assume that there is a B to A conversion as well, and with some value, so you are able to do that with some X cost. Now once you have done this with X cost, we are not allowed to touch this again. In other words, this entire thing is already fixed, right? So now we have to figure out what is the total cost to convert this string into this string. Now again, exactly the same problem, right? What is the minimum cost required to convert a string to a different string? So hope you can see the recursion here. Let's just formalize it. Let's say f of I denotes what is the minimum cost to convert the string starting at index I to the target string starting at index I. So if I is this, it means what is the minimum cost required to convert this string into this string, right? Now what will be the value of f of I? Again, either you will not touch I at all, ith index at all, and when you can do that, only when you are sure that they are equal. But if they are not equal, you have to touch it. Now if you have to touch it, so first case is you are not touching it. In case you are not touching it, you are saying that minimum cost to convert everything starting at I plus 1 would be equals to minimum cost to convert everything starting at I. Again, this is half true, we'll come to that. But let's say you did this if it is equal, if ith character of source is equals to ith character of destination. But if they are not equal, you have to touch it. There is no other choice, right? Because you have to convert this string to this string. So if they're not equal, you have to touch. Now you have few choices here. Either you will touch only C, or you will touch CD, or you will touch CDA, or you will touch CDF, and so on and so forth. So let's say you have touched everything up till J. So now what will be the cost? So if you touch everything up till J, the cost is the shortest path of conversion of everything from I to J of source to target. Basically you have to convert CDAF to BCDF, and you have to figure out the shortest path for that, right? And f of j plus 1, because everything after j you need to still convert to the target one, right? So hope this point makes sense. So let's just look at the pseudo code, and then we'll look at we'll do a dry run to understand this a bit better. So what we have here is we are trying to find out f of index, which denotes what is the minimum cost to convert everything starting at this particular index all the way up to end. Now this DP is memoization, we'll come to that, but if source index is equals to target of index, if the character is equal, we can simply skip touching this, or skip applying any kind of transformation to this particular character, and say the result would simply be f of index plus 1, right? Notice that there is no else here. So basically if they are equal, then also we are doing this thing. Why? We'll come to an example, but here what we are doing, let's say they are not equal. For now assume this, they are not equal. So what are the choices? We can either touch this alone. Touching this alone means that your task is to convert this B into this A now. So you have to somehow figure out what is the shortest path to convert the given substring to a target substring. So that, and what are the operations available? Operations available would be the given original and changed values in the problem, right? Now once you figure out this conversion cost, you can simply add the cost to convert the rest of the string, and this will give you the minimum cost if you decided to convert everything up till this match of index, right? Now you will try out every possible match of index and take minimum across all of them, and that will give you the minimum number of operation to convert the given string into the target string starting at index ind. Now the same index can repeat again and again. So to avoid calculating the values for the same index, we just done memoization, so that we will not end up calculating the same thing, the value for the same index again. And finally, let's say they are equal, let's say A and A are equal. So we have to still do this entire thing in that scenario as well. We can't simply say that not applying any operation is the best thing. Why? Let's take this same example. In this example we know the answer is 6, right? But let's say there is one more transformation available, which is transforming ABCD A to AABCD, right, with just a cost of 1. So if it is available, then you will surely apply this transformation and convert this ABCD to ABCD, and this entire string would now become equals to the target string with just one operation, with just a cost of 1, which is less than cost of 6, right? So even though the character is initially equal, it might be possible that there is some transformation which will help you transform some other characters on the right, which are otherwise hard to transform. By hard I mean you need more operations and more cost to transform. So that's where, even though the character is equal, you will still apply the entire algorithm for that trait. Means you will try to transform the given um, either this character or this string or this string or this string and so on and so forth. You will try to transform everything starting from that character as well. Now there are what is the time complexity now? So time complexity is you are doing something for each index. So total n indexes are there. Now what you are doing for each index, you are doing a for loop here, right? So again this for loop can go all the way up to n. So you are doing something inside the for loop. What you are doing, you are first figuring out a substring here, right, and another substring here. So this will be an order n operation, right? Again an order n operation because you are figuring out substring, and then you are figuring out some shortest path. So that is, let's say, denoted by s. S denotes the shortest path from some source string to some target string. So overall complexity is n cube into s, right? Now this n cube is not exactly n cube, right? Because the value we will look at it. So let's park this for now. We'll look at what exactly this n cube denotes, but for now we need to figure out what this s looks like. We need to figure out what is the shortest path, or how to figure out the shortest path from some string, let's say abc, to some target string xyz, right? Now how will you do this? The answer lies in the fact that let's say abc is the source string. You are sure that you will be converting this abc to a string which is of same length. Why? Because original I of length is equals to changed I of length, right? So whenever you take a substring of some size, you will be converting that substring to exactly same size afterwards. Now once you have converted this to exactly same size, again you can apply some more operation here because the size is same. So the substring you will be picking, so let's say bcda you picked, you transformed to dddd. So the substring dddd is eligible to be transformed to something else now because the size is same. If the size would have been different, the previous criteria that you can only touch the exact string or don't touch at all will not be satisfied. So because the size are same, you are free to do as many number of transformation as you want and finally reach the target string. So isn't this problem exactly similar to the previous problem, like where we have been given a character and we follow some character to reach a final target character? The only difference here is instead of character we now have a string. So let's just transform each string to a number or a character, whatever you call it. So we transform this bcda to 1, we transform this ddd to 2, abcd to 3. Basically we just put a map and assign numbers to each of these string. Now after you assign number, you can form a graph. So you can convert 1 to 2 with a cost of 4. Similarly you can convert 2 to 3 with a cost of 3, right? Similarly you can convert 4 to 5 with a cost of 6, and finally you can convert 6 to 7 with a cost of 1, right? Now once you found this graph, you can simply figure out what is the minimum cost required to convert a given number to another number. Again you can apply shortest path algorithm for every node, either using Dijkstra or use Floyd-Warshall to actually compute the shortest path from every node to every other node. So this denotes that shortest path from 1 to 5 is infinity, right? Similarly, shortest path from 1 to 7 is infinity. Basically you can't reach from 1 to 5 because there is no edge at all, they are completely disconnected. Similarly, the shortest path from 1 to 3 is 7, which is true. The shortest path from 1 to 3 is 7. So you can do Floyd Warshall and come up with this table. Now once you have this table, answering this problem is straightforward. What you can do, you can simply look up this source string and figure out the particular value. Once you figure out the value, let's say x, you can look up the destination string as well, figure out the value, let's say this is y. So you can just go to yth column, and whatever is the value at that will be the shortest path from x to y, and hence this s is nothing but order 1. So overall complexity here is order n cube itself, right? Now let's just do one final dry run. So before we move forward, this solution will pass. Again, this is not the most efficient solution, but this will pass because of how the test cases are arranged. Again, in some scenario it might not pass. I will show you one code where this will work, but I have coded it in different formats with slightly different data structures, like another map instead of map, or set instead of map. And some of the solutions were getting TLE'd on 600x test cases. So if you are able to pass 500 test cases, it means your solutions are correct. And if you understand the time complexity of the solution, I would say you don't need to waste time here and get it accepted, because the time constraint in this problem is not that good, right? So let's just look at or let's just do a final dry run before we look at the code and further follow-ups. So we have converted each string here to some number, and based on that we figured out the shortest path from every node to every other node, right? Now we want to find out the minimum operation here. So in other words, we have to find out f of 0, the minimum cost required to convert this entire string to this entire string, right? So what we have discussed, we will first figure out what to transform. So either we can transform this, there is no a here, right? So we can't transform this, or we can transform this. Again, there is no ab here, so we can't, like our source will not be present, so we can't transform. We can transform this, no, abc is also not present in this list. We can transform this, again no, because abcd is not present in this list. Notice that abcd is here, but this is the destination side. We want the source to be abcd, which is not there, right? Now similarly abcda, which is also not there, and you can figure out the rest, it will not be possible. Now because a and a are equal, one case is possible, which is try out f of 1, and whatever is the value of f of 1 will be the value of f of 0 as well, right? So because they are equal, you will now figure out f of 1, which is the minimum cost to convert this string to this string, right? Now let's look at this, right? Again, they are not equal, b and a are not equal, so this from f of 1 you can't directly go to f of 2, that is not possible. So where you can go, so you have to transform. So can you transform b? Again, b is not present here, so you can't transform b. Can you transform bc? Not, because it is not present here. bcd? No. bcda? Yes, bcda is present here, so you can transform bcda to something. So which thing you want to transform bcda to? You want to transform bcda to abcd. So the value of f of 1, or one value of f of 1 would be the shortest path to transform abcd or bcda to abcd, shortest path, right? Plus f of 1 2 3 4 5, right? Basically, what is the minimum operation to convert this string to this string, right? So f of 5 will be 0 because they are already equal, so let's just forget about this. So this is 0. Now we need shortest path to convert BCDA to ABCD. Now what is BCDA? BCDA is 1. So BCDA is 1. So destination is ABCD. ABCD is 3. So ABCD is 3. Shortest path between 1 and 3 is 7. So the value of this would be 7. So one of the value of f of 1 is 7, right? Now let's move forward. Can we convert BCDAF? Answer is yes, because there is a BCDAF in the source array as well. Now if we are transforming BCDAF, we need to transform it into ABCDF. So another way would be shortest path between BCDAF to ABCDF, right, plus f of 6. Now f of 6, again you can take it as 0 because they are already equal, so f of 6 would be 0. Shortest path between BCDAF and ABCDF. So BCDAF is 4, ABCDF is 5. So source is 4, destination is 5, the shortest path is 6. So the value here would be 6. So f of 1 would be minimum of 6 and 7, which is 6. Like, let's just first go and see, are there other transformation as well? Can we transform BCDFG? The answer is no, because BCDFG is not present and anything else is not present as well, so we can't have any other transformation. So the value of f of 1 would simply be minimum of 6 and 7, which is 6. So the value of f of 1 is 6. Basically we require 6 operations or 6 cost to convert everything starting from here to the target string starting from position 1. Now, and once we calculate f of 1, we will calculate f of 0 as well, which is equals to f of 1, because we have taken the path where both are equal. We haven't transformed anything. So f of 0 will also be 6, right? So hope this entire solution makes sense. If you have any doubts, feel free to post them in the comment section. Now if you have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because that's the point where you will understand which part is not clear. This time I would not ask you to get it submitted and get AC, because time constraints are bit harder and it depends on various factors, right? So anyway, let's look at the solution. So we'll look at the solution that we just discussed first. So we first converted everything to a particular value, right? So we created a map of string int and put everything in original and changed to this map. Once we have done that, we assign each label to one string, right? So we have now this map built out. Now once we have this, we will simply do floyd varchel to compute the shortest path between every node to every other node. So now after this we have this built. Once we have this, we now have to figure out basically start from a particular character and then try out everything else. So if you do this top-down approach, I was getting TLE even though the complexity is exactly the same. So what I have done, I've tried a bottom-up approach, and just to be honest, this code that I'm showing is not mine. I have just copied it from some solution of the Leetcode. Mine solution was exactly same. I will show you that as well, but just a bit difference there, and because of which it was failing last few test cases. So I tried, but I was not able to get it submitted, even though the code is doing exactly the same thing. Nothing different there. Anyways, let's move forward. So after that, we now figured out what is the length of strings present in original array. In other words, remember that we have to first check whether whatever we want to transform, whether it is present in the original array or not. Now instead of checking every string, what I have done is I have just taken unique lengths here, right? So I know that we have a string of length 4 and we have a string of length 5 only in this particular array, so we can't convert a string of length 3 to 1, so there is no point checking those lengths of string at all. So for here what we have done is we uh, we simply take the unique lengths here, and once we figure out the unique lengths that we have in our given array, we only iterate over them. So we simply iterate over the unique lengths that we have, and if we figured out what is the source and the destination, once we have figured out the source and destination, we look up the map and figure out their indexes. Once we have the indexes, we simply do a min operation with the value of the indexes. So this is the source index, this is the destination index, and this in total will be added up with dp of I minus l plus 1, because if you remember we were adding it with f of match index plus 1 as well. So this is the entire thing. We have already discussed how to convert top down to bottom up, so you can simply convert this to bottom up, and this will be looking something like this only. Only difference is we are not trying out every possible match index, we are only trying out those indexes for which we already know that we have that length of string in the original array, otherwise there is no point trying, right? So that's the only optimization here. The overall complexity still order n cube. Now this solution will pass, but as I mentioned, like it is on the border, and we can do much better than this. How? So let's look at it. We have to optimize this particular solution, so let's just get rid of some of these, right? So we know that we have to iterate over the length, all the lengths available in our original array. So this n we can't avoid, this n we can't avoid, right? Only thing we can avoid is avoiding if we can actually go through and figure out what is the exact string here, right? If we are able to directly get the source index and destination index without actually making this arrays, we can simply do this source comma destination index and look up that 2D matrix to figure out the value. So this n, third n, will go away if we are somehow able to figure out the source and the destination index without actually calculating the actual substrings, right? So that's the task. Now how will you do that? So our job is to figure out at B, if we have to consider length of 4, what is the index of that particular string in our map? So I would encourage you to pause and try to think about this problem by yourself for a moment. So hope you have at least thought about it. The solution here is pre-computation. You have to do some sort of pre-computation to avoid actually making the string and then figuring out what is the index. So one way could be, okay, let's say you started a for loop for each of the indexes, right? So for now you are at index I. Now for index I, you iterated over all these values of original. So you iterated over length of 4, length of 5, length of 6, whatever length we have available, and based on that you figure out what is the indexes for them and store it here. So you basically, we are preparing another 2D matrix here, which is dp of I comma l, which denotes what is the index of the string formed starting at index I and considering a length of l. What is the index there? So for example, in this case, if we consider dp of 1 comma 4, the value of index would be the index of BCDA, which is 1, so the value would be 1, right? Similarly, dp of 1 comma 5 would be the index of BCDAF, which is 4, so the value will be 4. So if we have this matrix with us, we can figure out the value of source index and destination index in just order one time and avoid this extra n, right? So that's exactly what we can do using Rabin-Karp or hashing or any other string matching algorithm. Basically, what we want to know, in this string, where all BCDA occurs. Similarly, in this string, where all BCDAF occurs. Similarly, in this string, where all DDD occurs, and so on and so forth. Now, once we have figured out that, filling up this metric is not hard, right? So I would strongly encourage you to pause and at least try to visualize this and code this and extend your previous code with this particular solution. So next we'll be looking at the code. Again, I am not doing the exact dry run because this is slightly advanced, and unless you try it out yourself, even though I will show you the entire thing, you will not be able to sustain that and apply it in future contests. So it's always better to try this kind of things by yourself before looking at the solution. So next we're looking at the code. The code is also almost similar. So what we are doing, we first prepare this map and do Floyd Warshall. So we have this map ready and we are also done Floyd Warshall until this point. Now after that we are applying Rabin-Karp algorithm to figure out where all this particular string s occurs in the given source string. So we get a list of indexes. So let's say we get 4, 5 and 8. So at index 4, starting at index 4, I have a BCDA. Starting at index 5, I have a BCDA. Starting at index 8, I have a BCDA. So what does this mean? This means that starting at index 4, if I need a length, if I extend my length to 4, I will be getting BCDA, the index of which is 1, right? So dp of 4 comma 4 would be 1. This is what we will infer from this particular list. So that's exactly what we have done. We iterated over each of the indexes and we maintain another array match of src, which the value of which is match of src of I to length is equals to index. Basically, if we start at index I will be getting this string s. So basically, if I extend a length of s dot length, I will be getting this particular index, right? The same thing we have done for s of changed as well, because this is what we will use for the destination part of it. So we have to figure out the source and the destination. So source and the target. So for source part we have match of src, destination part we have match of dst. Now once we have these things calculated, in the inner loop we don't need to figure out the actual substring. We can simply look up these arrays and figure out the values. So notice we are now avoid calculating the substring, which can take order n time in worst case, and hence we have reduced the complexity from order n cube to order n square here. Now unfortunately even this was not passing because this piece is of the order of n square or 2n square, which basically I have n square most of the time here. So that's where this is also not fully passing. There are a few test cases which are left at the end, but the complexity, the worst case complexity of this solution is a lot better than the previous one, because Raven carp will work just in order n time, and we are doing this for n number of string. So order n square here and order n square here, right? So with just 2 order n square we have removed 1 order n cube. But now because n itself here is small, kind of 100 200, this kind of optimization is not prevailing and causing extra overhead for the for what it's worth. So basically sometimes it is getting time limit exceeded, or sometimes it is accepted. So but even though it is a better solution, and I hope you understand the thought process. So with that I will end the video here. If you have any doubts in any of the piece, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.